Welcome. So in this video we will learn about the plasmin action on beta-casein. So plasmin is a indigenous proteinase, and if you see the structure of beta-casein is having N-terminal amino acid is the arginine, and the C-terminal amino acid is the valine. So this is N-terminal and this is C-terminal. And if you see the plasmin is an indigenous proteinase and is highly specific for peptide bond with lysine at N-terminal bond. So if lysine is there at the N-terminal bond, for example, in case of beta-casein, the three specific position at which plasmin will act is 28, 29, 105, 106, 107, 108. So 28, 29, 28 is lysine. Here we can see lysine, and here also 105 is lysine, and 106 can be histidine or glutamine depending on the different variants. So it can be histidine or glutamine, and 107, 108 is lysine and glutamic acid. So here we can see that N-terminal, that is 28 is also lysine, 105 is also lysine, and 107 is also lysine. So plasmin is specific for those peptide bonds which are having lysine at the N-terminal of the bond. So these are the position, plasmin on either 28, 29 position, 105, 106 position, 107, 108 position, and it are hydrolyzed rapidly at these bonds. The resulting C-terminal will be called as the gamma fractions, and the N-terminal peptides will be called as the proteose fractions. So C-terminal, if you see, that is the 29 to 209. This is the C-terminal ranging this 29 to 209 will be called as gamma 1. 106 to 10209 will be called as gamma 2. 108 to 209 will be called as gamma 3. And now if the N-terminal peptides are called as proteose peptide fraction, and see 1 to 105 is pp5, 1 to 105 is pp5, 1 to 107 is pp5, and then 29 to 105 is your pp8, and then 29 to 107 is your pp8 slow. This 29 to 105 is also pp8 slow, and 1 to 58 is called as pp8 fast. So these are the N-terminal components of the fractions which are obtained on action of the plasmin on the beta-casein. Now gamma 2 and gamma 3 are temperature sensitive, since they are soluble at low temperature but aggregated on heating. So these are temperature sensitive. Now why to call pp8 5, pp8 slow and pp8 fast? Because these fractions pp8 fast move faster in the electrophoresis. It has been observed that pp8 slow have slower mobility towards in electrophoresis due to high amino acid residues, whereas pp8 fast is having higher mobility in electrophoresis due to low amino acid residues. So in pp8 fast we have only 29 amino acid. Here we can see 1 to 28, whereas in this case we are having more number of amino acid pp8 fractions. So these are called the pp8 slow, and these will move slowly in the electrophoresis when separated by electrophoresis. Now there is another fraction which is another component of the protease peptide fraction, which is called pp3, and protease peptide fraction of milk protein is very complex mixture of peptides, most of which are produced by the action of indigenous plasmin, but some are indigenous to milk also. So most of the components of the pp fractions are produced by the action of indigenous plasmin, but some are also indigenous to milk. So pp3 fraction is indigenous to milk. And pp fractions which 5, 8 slow, 8 fast, which I have studied in the previous slide, have little or no technological significance, whereas protease peptide 3 have several interesting technological functionality. So pp3 is technologically is more important, and pp3 is heat stable phosphoglycoprotein. So it is a conjugate protein that was first identified in the protease peptide fraction of milk. So it is a heat stable phosphoglycoprotein, and unlike other peptides in the fraction, pp3 is indigenous milk protein and synthesized in the mammary gland. So it is not it's from the plasmin action of the beta-casein, but it is the indigenous milk protein, and it is synthesized in the mammary gland. Now if you see bovine pp3 consists of unlike other peptides in the fraction, we have pp3 is the indigenous protein synthesized in the mammary gland. Now bovine pp3 consists of 135 amino acid residues with 5 phosphorylation and 3 glycosylation sites. Now pp3 consists of 135 amino acid residues with 5 phosphorylation and 3 glycosylation sites are there in it. Now when isolated from milk, pp3 fraction contain at least 3 components. 3 component होते हैं, molecular weight 28, 18 and 11, and the largest जो होता है उसको हम pp3 बोलते हैं, और smaller components होते हैं they are the fragments therefore generated from plasmin. So pp3 is mainly present in acid way and also some present in milk fat globule membrane. So it is also, some is also present in the milk fat globule membrane. Now owing to its strong surfactant properties, pp3 can prevent the contact between the milk lipase and its substrate, thus preventing spontaneous lipolysis, and its emulsifying properties have also been evaluated in dairy products such as ice cream and recombinant dairy cream. So owing to its strong surfactant properties, pp3 can prevent contact between the milk lipase and its substrate, thus preventing spontaneous analysis, and its emulsifying properties have also been evaluated in the dairy products like ice cream, and so it is also having the emulsifying properties. Although its amino acid composition says that pp3 is not a hydrophobic protein, but it behaves hydrophobically. Why? Because it forms an alpha helix, one side of which contain hydrophilic residues, while the other side is containing hydrophobic amino acid residues. So it is behaving hydrophobically. So we have seen the significance of pp3, the technological significance of pp3 we have also seen. Thank you.